Welcome to Cpp.chat, a colourful look at what's going on in the world of C++, chatting with guests from the community. But before we get too graphical, John has a disclaimer to read.
Thank you, Phil. Actual colors may vary. This is due to computer monitors displaying colors differently, and everyone can see these colors differently. We try extremely hard to ensure our photos are as lifelike as possible, but please understand that actual color may vary slightly from your monitor. We cannot guarantee that the color you see accurately portrays the true color of the product. All right, so very excited to have our guest, James Berrow on. Did I say that right? I never asked you.
No, everybody spells it wrong. Everybody pronounces it wrong. It's James Berrow.
Berrow.
Fine.
Okay.
It is an invariant of the show that when John says, "Did I get your name right?" it's completely wrong.
I'm never as optimistic as to say, "Did I get it right?" I always ask, "Did I get it wrong?" because that's usually the case. So I'm dying to get into the meat of our interview. I have tons of questions for James, but we want to kind of do the roundup of the news. Phil, what should we talk about?
I thought it's just worth mentioning that it was the last CPP cast episode. It's now, I think, the one before that was Hannah Dusikova on to talk about the Prague ISO meeting. Obviously, she was hosting it. Well, Avast was hosting it, and she was instrumental in that. So that was a great catch for CPP cast. So if you want to catch up on what happened in Prague, make sure you listen to that show.
And maybe we'll get the link up to the video that Bryce and Connor put together. They did a video to celebrate
It's a good video.
20. Yeah, it was kind of fun. Yeah. And what else is going on? ACU 2020 coming up soon?
Yeah, that's just going to be next month, which is, well, just a few days away. The month is a few days away. The conference is 2 or 3 weeks away, but that's coming up fast. So worth mentioning that if you're in the UK or accessible to it and thinking of going to a conference soon. Obviously, we don't know yet, actually, about any of these conferences, if they're going to be affected by coronavirus. Been hearing about a lot of events being cancelled due to travel restrictions, but I've not heard about that in any of the C++ circles yet. So we'll be keeping an eye on that, particularly those coming up soon. I
heard from one organizer that a speaker canceled because their company is forbidding any travel at all. And that's like, oh, that's just, as an organizer, it's going directly into my heart. Speaking to heart, there is something else I want to talk about. This is kind of serious. So at C++ Now, we have a program. It's the student volunteer program. It's a little bit competitive. We get applications, and initially the deal was just that we would waive registration for someone that was accepted. They still had to pay their own way. Bryce worked really hard with students to get their companies, or their schools, to help them pay. But for undergrads, that's unusual and a little hard to do. For graduate students, there's usually some budget for that. Anyway, what happened is that the Boost organization stepped up and said, we will commit up to $10,000 a year to fund travel and lodging for this program. And that has allowed us, Bryce is really good at squeezing the last dollar out of travel. And we have the student volunteers share rooms and things like that. So we usually get 4 to 6 people we can afford to bring in. And that's been great. But this year, for reasons that I'm not really certain, it may be that Bryce was really successful at promoting the program, we got 46 applications, which is more than twice what we've ever gotten. The number has been going up a little bit every year, but this year it just shot up. And these are not bad applications. I mean, I'm not saying every single one is great, but this program, and I want to say this program has produced people like Louis DeYoung, Vittorio Romeo. I shouldn't have started mentioning names because then you go down this thing of, oh no, who did I forget? I've forgotten a lot of people. We have 3 people who are speaking at C++ Now who won't be able to come if they're not accepted as student volunteers. They're part of the student volunteer program. All of these guys have, happens to be 3 guys in this case, but all of them have attended before as student volunteers. And generally what Bryce tells them is, if you ever want to come back, you have to be accepted as a speaker. It's not technically true, but that gives that gives them something to shoot for. And usually we get student volunteers submitting as speakers at C++ Now, CPPCon. I mean, this is a great, amazing opportunity for them, but it's great for the community too, because I feel like the average age of C++ programmers is getting higher, and that's not a good thing. And so this is a great opportunity for young people. And so I am trying to make the case to the Boost organization that we need to step up a little bit more money. But I'm also, and that's why I'm mentioning it here, I'm appealing to the community. We're working on a GoFundMe or something like that. But if you feel like you want to support young people, people who are young and excited about C++, and I will tell you this, as part of their application, they write an essay about their experiences in C++. And I actually get a little teary. Now, maybe I'm a little weird about C++, I don't know. But when people are talking about how they discovered, you know, these are people who aren't necessarily, you know, socially, let's just say they're awkward socially, potentially. And then
say they're programmers.
And they express themselves. And it means a lot to me. And I hate saying no. So that's why I'm reaching out. And so, you know, those people who watch the show know I'm not a shill for money on this show. This is the first time I'm blatantly saying, if you can support these young people coming to the, if you can support these people coming to the conference, these are great applications. We squeeze a lot out of the money you give, and we get huge return from what these people are contributing into the community. So contact me or go to the cppnow.org, cppnow.org website and look for individual sponsors. If your company can sponsor, that's great too. Contact me and I'll send you a prospectus. Anyway, so that's my spiel. And I mean this very sincerely. I put in my own money every year to the Boost Scholarship Fund, which is what funds this. And part of the reason is, as I say, I read the applications and we just can't say no to these guys. We gotta have. I should say, guys, we had more women apply this year than we've ever had, and so it's great. And so I'm asking you to please step up. And thank you for that, letting me put that little ad in there, Phil.
I'll edit it all out.
That's right. Take it all out. You won't do that because you have met these student volunteers. Am I exaggerating about their contribution to the?
No, absolutely not. It's a really great opportunity. So I really love that program.
We're on point with the SFX today.
Yeah, I was going to say, people thought I laughed at you when you said that, and what I was laughing is the visual effect you did when you did that. No, because this is really serious. All right. So are there other things we want to talk about? Speakers announced on C++ on C?
Yep. So announced a couple of weeks ago. I was meant to follow up fairly shortly with a full schedule, but I've been a bit behind on collecting information on that. So
I think I owe you an abstract.
Yes, that too. So just collecting all that information together. Hopefully by the time this episode airs, that will be out as well. Also wanted to mention.
I should say about this, because I'm still on my spiel here. If you're listening to this and it's been several weeks since it's been recorded or something like that, please go ahead and make a contribution, because we do this every year. This year is amazing because we've got so many, and I don't know if that'll happen every year. I don't know if this is the new normal or if this is a once spike, but it's a great program to support, and I appreciate supporting. Sorry.
That's fine. Just wanted to mention briefly Core Hard Minsk. I'm not sure we don't mention that one very often. It's a bit of a smaller conference, but they had that twice a year, and the next one's in April 10th and 11th.
Not far off.
It's not too far off, and I just found out that I'm actually giving one of the keynotes. So
congratulations!
There. So,
fun.
Absolutely. Belarus.
Yep, that's the one. And I actually have a relative living there as well, so I'll get to see them. So,
all right. I have never been to it, but I have met some of the people who organize it, and they seems like a great opportunity. And again, congratulations to you, Phil.
Thank you. Yeah.
All right.
I think that's all the news we have for this week.
Cool. So let's dig in. So James, I first heard of you because I read the review that you wrote about the proposal. Do we want to start there, or where do we want to start?
Yeah, we can start with color theory, give a little bit of background. I mean, the proposal goes through sort of background and introduction to color theory in light, tries not to go too deep into it because it's a monster topic that we could talk about forever.
Okay.
And then after that goes through more general issues with the graphics proposal. So start with color, that takes us through the graphics proposal and the issues with it, and then move on to wider stuff. Guess could work.
All right, so maybe you can solve a problem for me that I had. I was working on the conference, and one of the things with the conference schedule, we like to color sessions to kind of communicate something about the session. So we group the sessions, like those that are about, template metaprogramming, get some color. Those that are about embedded and auto and things like that, get another color. And so we try to do this. And of course, it's really hard to categorize these in a small number of categories. So we end up with a lot of categories, and we need to color them so they are as distinct as possible. And so I figured, well, this shouldn't be that hard, right? It's just
shouldn't
numbers.
Be that difficult, should it?
So we just find numbers that are as different as possible from other numbers. And you know what? That didn't work.
No.
Why the heck did that not work?
Oh, you've opened a minefield here. You've opened the biggest can of worms, because this gets right to the center of the problem, is that the way that we perceive colors is not very easy to define, right? Computers, the representation that we have of colors is not well suited for doing that for common stuff, right? So you have something like HSV, right? You have hue, saturation, and variance. You have a little color wheel, and you pick colors based on that. You pick your saturation, and you pick your the other parameter. It's rubbish. It's not perceptually uniform at all. So you'd think you'd just be able to pick colors off this nice wheel. Everybody does it, and they come out looking terrible. It's a big problem. Just trying to pick distinct colors. You have to go relatively arcane to be able to do something like that. There's a color space called L star UV, which nobody's heard of unless you do color management, which is great for doing this kind of thing, but it shouldn't be that complicated, but it is.
Okay, hang on. So L star UV, and what is that doing that's different than other color spaces? So let me point this out. This was something that was a surprise to me. I knew about RGB, but actually there's a whole bunch of different color spaces, right?
Yeah.
I mean, a whole bunch of different way of breaking, because if you think about it, computers are all about transferring the world we know into some kind of number. And sometimes it's just arbitrary. When we talk about characters, we should have a show on Unicode sometime. When we talk about characters, we just arbitrarily assign a number to a character. That's fine. That's great. But when we talk about most other things, it's kind of a natural. I mean, if you're talking about distance, it's pretty obvious. You pick some unit, and that's the distance, and you make it a number. And most things we do that way. But if you think about color, oh, wait a minute, that's weird. Because if you only think about black and white, well, then that's easy. It's just like temperature, right? High numbers mean this, low numbers mean that. That's easy. But when you think about colors, well, how could you convert? I mean, again, you could arbitrarily assign, say, okay, well, green is 3 and blue is 4. Well, that doesn't really scale very well.
No. Well, so I'll explain. So the fundamental discrepancy that you run into is that if you have a light and you have a certain amount of light being emitted from that light, say you have a red light and you emit a certain number of photons per second out of it. If you emit twice the energy out of that light, to a human being, it's not twice as bright. That's the fundamental discrepancy here, is that human perception of color is nonlinear. And that's the mistake that people make absolutely all across the color world, is that fundamentally twice the brightness out of a lamp is not twice the brightness to a human being. That is where you run into all of the issues. Is
that just a, almost anytime you work with physics with distance, it's a square rule? Is it just that you need to take, how do I say, is human perception still regular? It just has a square rule or a square root instead of linear.
Human perception is basically very non-linear. It's the same problem that you run into with sound, in that you take decibels, and 20 decibels is twice as loud as 10 decibels, but it's a power of 10 law. So the difference in power emitted is enormous. It's the same problem with color, and it's not quite the same scale of like power of 10s, but the human brain, the human eye does not perceive stuff linearly. And it would be really great if it did, because it would make my life a lot easier, but it just doesn't. And it's just been ruining everything forever. So if there's one change that I could make to human beings, it would be that. But it's not going to happen anytime soon.
There isn't an evolutionary solution here. Have you come up with some genes that would?
not in the near future. But I'm going to pick you up on something that you said, which is where you said RGB, right?
Okay.
RGB. The takeaway from this talk is that RGB doesn't exist. It's not. You should never talk about RGB. This is the fundamental problem that we run into. So when people say RGB, you have three values, but what matters is what those three values represent. So RGB, as most people think of it, is actually sRGB, right?
I don't know.
It is.
Okay.
So normally, if you take if you just Google a color off the internet, it will be sRGB. You have some values which are between 0 and 255, and those are great for displaying in your computer monitor. But you can't do maths on them.
And what does the S stand for?
Standard, I think. Somebody asked me this the other day, and I had no idea, and I felt like a bad color engineer. There's sCRGB.
Is that what you are? You're a color engineer? Do you say that at parties? What do you do, James? Oh, I'm a color engineer. Can you engineer me some green?
Because nobody understands what's going on. I was talking to some game developers at Prague, and they went, "Oh wait, hang on. We do color completely wrong. You're right." And that's terrifying when just members of the industry suddenly realize that they've done everything horribly wrong.
Well, better the game industry than the transportation industry, I suppose.
Yeah, you don't. Yeah, at least we're not crashing anything into anything else. So one of the things I did was a review of the games industry. So I went through common graphics toolkits, stuff that people use, right? SDL, SFML, ImGUI, Unity, Godot, Ogre, and the Unreal Engine, as well as Flash. I didn't review Flash because nobody uses it anything for more, and I'm incredibly glad it's dead. But so I went and reviewed all of these tools, and the number one takeaway from it is that all of them do it horribly wrong. It's all broken. The industry is just completely broken.
Let me ask you this, though. Are they all doing it wrong the same way?
There's categories of errors that people make. So the Unreal Engine is the only one that does it right. And the rest of them...
Oh, you mean it actually is doing linear...
It actually is doing linear color right. It does everything correct as far as I can tell. That's the only one that does it. All the rest of them make a wide variety of mistakes. It's really bad. Like some of them you just can't use correctly. Like SFML provides a color class. There is no correct way to use it, which is baffling because people use SFML for everything. SDL as well makes the same kind of mistakes. ImGUI, I'm trying to fix it in ImGUI. I'm submitting a PR to try and get it to work.
So I'm not a game engineer. Is the Unreal Engine touting this? Are they? I mean, somebody at Unreal didn't just stumble onto this. Somebody actually understands it, right?
Put a massive amount of work into getting it correct.
And then why?
You would think that they would. You'd think they'd turn up and go, the Unreal Engine actually does this correctly. But I think the problem is it's one of these things. And one of the main takeaways, I think, from this talk is that it's not that complicated to do color correctly, right? You just have to know that it's a thing that you need to handle correctly. So you can actually get away with relatively basic maths. You just need to know what you're doing. And then the actual complexity of implementing it is not that high. But the main problem is that people don't know that this is a thing that you need to be aware of. They don't know the difference between linear color and sRGB, for example. And they don't know that there's only certain kinds of operations that you can do in one and certain kinds of operations that you can do on the other. So it's it's a total mess.
So if instead of using RGB, if I had been using this linear color, whatever that is, when I was trying to pick colors that were distinct to color sessions on a schedule, then I could have done the kind of math that I was trying to. I could just.
Oh, not even then. So it gets worse, right? It always gets worse. If you think that you know what's going on, there's another layer, and then it just gets much worse.
Oh,
so
good.
The fundamental problem is that linear color. What linear color is that say I have a green light and a red light, and I shine them both on the same spot. The added together power of what you see, right? Not what you perceive, but the amount of light that comes out of those two lights added together. That's a linear, just adding together of those two powers. And so when you're dealing with emitted light coming out of lights, that's linear color, right? When you're dealing with color as humans perceive it, that's not linear color. So Linear color is good for doing like reflection equations on. So if you want to calculate how much energy reflects off a table or something like that, linear color is great for doing that. And you don't want to use sRGB for doing that because it will be all horribly wrong. But if you want to calculate how a human perceives a color, sRGB is great. But it's difficult to use sRGB to pick two colors that are far away from each other, because what you really want is a color wheel. You want just like a nice wheel where you can go, oh yeah, you know, this color over here is this different from this color over there. So
is
you
that
actually,
HSV?
HSV is not very perceptually uniform. So people have tried, right? So people have tried with HSV, and so people reach to HSV because it's got a wheel in it. It must be good. But it's not. HSV is also rubbish, just because the definition of it's not very good. And so you should never use HSV for anything. That's all I could say. There are better alternatives to HSV. Generally, if something's got a star after it, like H star, like L star UV, it means that people have thought about the like making it absolutely perceptual, like perceptually linear, so that it's actually like a good color space. But you want to use something which is not HSV, basically.
Okay, I sidetracked you. I'm sorry about that.
That's fine.
So we were talking about what RGB is actually good for, and that's perception, human perception.
sRGB specifically is.
So are you saying, I mean, if I were trying to do, which I'm not, but if I was trying to do a game, and in this game there is a red light and a green light being shined on a table, I want to see what that is. Are you saying that using the linear wouldn't be the right thing to do? I mean, it would give me the accurate value, but it wouldn't look right to a human?
No, so linear in that case would be the correct way to calculate the reflected energy off the surface. So linear color basically is you always want to do maths on linear color. So if you've got any kind of maths, any kind of equation, you're doing it on linear color, right? If you want to add two lights together, you want to multiply them by some constant, you want to do anything with it, you want to use linear color, and that's the correct thing to do. So you end up with a linear color at the end of your graphics pipeline, but you can't display that on your computer monitor because your computer monitor doesn't accept linear color. It only accepts sRGB. And so the fundamental reason for this is because you can stuff sRGB into 8 bits per channel, whereas you can't stuff linear color into 8 bits per channel. And that's the whole reason that we have this mess. This horrible mess is basically for space compression reasons, because you just can't stuff linear color into as little space as you can sRGB, which is annoying, but it's just the way that it pans out. So when you get to the end of your graphics pipeline, you go, I want to put this color on the screen. Your linear color, you then have to convert it to sRGB or ask the hardware to do it for you, and then that's what goes on the screen.
Okay. I guess that sounds like it should be manageable. It doesn't sound like, as long as you know to do that, right? I mean, that's the problem. It's kind of like when we have a string of text and we don't know what the encoding is.
Yeah, it's exactly like that.
Right. And so it's not, if you know the encoding, you know, oh, this is about to be output, so I need to convert it to the correct encoding for this. And I can convert it because I knew what it was. But if I just have some arbitrary set of, here's 3 values, it's a color.
Yep.
That doesn't tell me anything. It's just like saying, here's a string of bytes, it's a string. If I don't know the encoding, it doesn't help me.
Yep. One of the particular problems that you run into with color with that is that a string of 3 values will often be somewhat like 0 to 255, right, which is 8 bits.
Yeah.
And people will often accidentally stuff color into 8-bit per channel types because they think, well, this is actually sRGB that I've got instead, and so I can store that. But you can't. And if you put a linear color into 8 bits, you end up with horrible precision loss. You get banding absolutely everywhere. And so a huge number of graphics APIs actually suffer from this. If you put in dark colors into them, when you've got sRGB frame buffers, you're dealing with linear color, you just end up with terrible banding. So you have the trade-off in APIs like this, which is either you have terrible banding or you have incorrect color management, and there's no in between. You can't get the best of both worlds because they've been designed incorrectly. Just hugely annoying.
So what is the problem there? I mean, I didn't quite follow. So you're saying that if I have done all my calculations linear, now I want to display it to the screen.
Yep.
There's no win there, or is it because the library was bad or the hardware is bad? I mean, why is it that I can't work?
I'll take the example of SFML because I know it very well. SFML has an SF color class, and so the SF color class is used for everything. It's just how you specify colors are going to go on the screen. And so the problem that you run into is that the SF color class only stores 4 UIN8s, right? Each for one of the colors and alpha. So you have UIN8 for R, UIN8 for G, UIN8 for B, UIN8 for alpha. But when you are operating SFML in linear color mode, UIN8 is not enough storage space to store your linear colors in. So the API is just fundamentally unworkable because you can't store a linear color in 8 bits. You end up with precision loss. You need 14 bits to be able to store a linear color.
So it's not the conversion from linear color into what I'm going to display on my monitor. It's actually trying to manipulate it before making that.
Yeah, it's trying to stuff it into your graphics API, which doesn't understand that linear color needs higher precision than sRGB. Because when
you're talking about the API, you're not talking about me talking to the monitor. You're talking about me trying to manipulate colors in a library.
Yes, so we're talking about SFML. I've got a triangle that I want to draw on the screen, and I've said, I want this triangle to be red, please, but I want it to be red in linear color. The API is designed so that everything is specified in sRGB, even though you need to run it in linear color mode to get correct blending and results and stuff on your screen. So it's an unwinnable situation.
Unless
it's really annoying.
Unless you do all of the calculation yourself and then just tell it the answer.
Well, even then, so you have a vertex that you want to put on the screen. You just have a point in space with some associated data with it, and one of those pieces of associated data might be color, or it will be color. But often the library will say, well, color is 32 bits, 8-bit per channel, and there's nothing you can do about that. So you're screwed.
Well, that's what I'm saying is you'd have to manage that entirely yourself.
And then you'd have to use a different library entirely.
Yeah, and then tell the library, okay, this is the color I want you to use for this.
Yeah, if it allows you to customize the types that are going through it, but they often don't. It's a big problem.
So, okay, so we kind of begin to understand the problem, but the problem seems pretty universal. I mean, you haven't told me anyone other than Unreal that does this right at all. And you were just talking about games. Are there other libraries out there that I could use for graphics? It's like, oh no, they nailed it on this one.
You wouldn't want to use them for game development. So, for example, Apple and Android both have their own color management on mobile devices, which do it correctly. They don't allow you to do potentially everything that you might want, but they've got a pretty full-fledged set of functionality. The problem that you run into there is that it's not really game development stuff, right? It's more for like, you take an image, you want to do it, put it onto a screen. And the actual main problem with all of this color stuff just universally is that it's not strongly typed. So the thing that Unreal does so well is that it has a type for linear color and it has a type for sRGB. And you can't mess that up. There's no way that as a programmer you can accidentally convert between the two or use them in the wrong place. Yeah, strongly typed. And so everybody makes the mistake, other than Unreal. I actually don't know of a library or games toolkit other than Unreal that's open source that uses strong typing for colors, which is crazy.
Yes, that is. What do you mean? What do they do for colors? It's just a 32-bit?
They have one color class, and that color class, the documentation won't say what color space it's in, so you have to go digging through the source code, which is firstly not very good. Even Unity, you have to go digging through you have to just guess as to what color space it's in. The Unity engine, and so you just have to hope that they've done it correctly, which they haven't. And so some of them will use the wrong kinds of data storage types, which is 8 bits. That's very common to do. SDL and SFML make those mistakes, as well as ImGUI. Some of them will have 2 modes that they operate in. So they'll have a linear color mode and a non-linear color mode. And the non-linear color mode is incorrect. So you sort of think, why does that exist? But they put both of them into the same color type. So you have no idea what you're dealing with. You've just got a thing, and it's in any color space, and you want to do operations on it. How am I meant to write correct code? And the answer is that people don't.
Okay. All right. So we've got this background that everything is awful in the color world. And then somehow you became aware of the 2D graphics proposal in the standard. So how you credit STL for encouraging you to write the paper? Did he introduce you to the proposal? I mean, how did this happen? So I assume the code you write is in C++.
Yeah.
So you're a coder, but you haven't been in the committee.
No. this is my first interaction with standardization at all. I've
Okay.
vaguely followed what goes on. Well, I follow what goes on with C++ because it's interesting.
Sure.
Like all of us here, we all like C++. But I've never had any involvement in standardization other than just posting on Reddit going, why is this thing like this? Like I think so many people do. Yeah, so it was STL really. He sent me a message on Reddit just basically saying, because I made a post just saying, I've noticed some weird things in the graphics post. He said, you know what, you should write it up into a paper because frankly, people posting on Reddit is just screaming into the abyss.
Yeah.
Which it really is.
Which could be therapeutic, but it's not
yes.
going to change what's in the standard.
No, it's not very helpful. And one of the things I didn't realize at the time was quite how few graphics developers are actually in the C++ committee. I think there was maybe 6 people there in total, which is not a huge number of graphics developers when you're trying to deal with something as large as C++.
Yeah.
So
we had the same, by the way, we had the same issue. And when you start looking at networking things, we have the same situation. There just aren't enough people who really understand networking, and they talk about ASIO and they just don't know what they're talking about. And that's the problem. So I don't know. Anyway, it's a problem for graphics. And so you looked at the proposal, but you had looked at it even before then because you were grumbling on Reddit. STL is the moderator, one of the moderators on the CPP subreddit. And so he sees this and he says, you'd be more constructive if you put your thoughts into a formal paper, and which could be he trying to be helpful, or it could be him just trying to shut you up.
No, he's one thing I'll say about the C++ standardization process. Everybody's been incredibly helpful and friendly all the way through. There's been no
and I know that
anybody trying to shut anything down. Everybody's been absolutely wonderful.
I know that STL is great, and
he's great. So he sent me this thing saying, go and actually put your thoughts into a paper, because basically the feedback that you're putting on here in Reddit, correct or not, it's actually not very helpful.
It's not going to go to the committee.
Yeah, so I'd had a skim basically of the graphics proposal, because it occasionally crops up on Reddit. People go, oh, the graphics proposal's still going around. And I thought, well, I know a bit about color management. I'll just see if they've made the same mistakes that everybody else has. And the answer was yes. So it didn't take that long to find.
So the proposal is actually based on a specific existing library.
Yes. So it's derived from Cairo, but it's diverged quite a lot from Cairo since then. But the fundamental initial version of it was derived from Cairo, and a lot of the API is still relatively similar to the way that Cairo works.
And what can you tell us about Cairo?
Cairo is very old at this point, and it's basically so Cairo has 2 major problems, which is that the performance of it is not amazing because it was designed in a time where graphics architecture was very different to the way that it is now. And the other angle of it as well is that it has no sRGB support, has no support for this linear color stuff. People have tried to stuff this in over the years, but the current version of it doesn't have anything. It's unworkable, basically. So those are the kind of 2 major problems of the performance and the color management in Cairo.
So this is, and I'm sure that the graphics proposal has really, really been controversial. And one of the points that was made is, should a library like this be standardized? And people were fighting huge wars over that. And I was trying to say, I have my opinion about that. But if you want a library, this isn't the one you'd want. And I thought that got overlooked. It was like, this is not a strong contender. If you were going to pick a library to put into the standard, and if everybody agreed, we need a 2D graphics library, it's appropriate, it's going to be worth all the time it's going to put into it, all those kinds of things, it's unlikely this would be the best choice. Am I wrong about that?
So one of the things that's very difficult about graphics is that graphics are a moving target. Right, I'm gonna put in the diplomatic answer here, which is that graphics is a moving target and it's fundamentally very difficult to standardize. Graphics architecture evolves constantly. The way that graphics worked 20 years ago is totally different to the way that graphics works now.
And part of the reason for that is because it is so important that hardware designers are throwing tons of work at this, right?
Yep.
I mean, and so if somebody can figure out a trick, a better way of doing something, that could generate ripple effects that libraries are now written differently because, hey, if I can get a 20% improvement in performance and all I have to do is completely rewrite my library from the ground up, some people are going to think that's a win.
Well, that's exactly what happened when Vulkan turned up. So the new generation of graphics APIs came along, and suddenly you had to rewrite all of your engine code. You had to redo absolutely everything because they were totally different. And to get good performance out of them, or to get the best performance out of them, you needed to fundamentally redo the way that you did all of your graphics. And so that is just a truth.
My argument then is, if that could possibly happen again, then what that means is the last thing we would ever want to do is put graphics into the standard.
So this is a very interesting conversation, actually. So there are graphics libraries that have
I hope so. That's why we're recording
it. there are, yeah, exactly. I'm going to tell you a really boring thing now.
Okay.
No, so there are graphics libraries that have existed that have been stable for quite a long time. So something like SDL has existed roughly in its current form for a significant amount of time. And SFML actually, despite all the problems with it around color management, has existed in its current form for a significant amount of time. So it's easier to standardize.
Is it staying performance? In other words, one of the things that we standardize is we never standardize an implementation. So if somebody made the argument, said, well, John, I can completely rewrite the library, the implementation side, every generation of hardware with no problem, then that mutes my argument. That is a strong refutation of my argument. If you assume you can do this without changing the API, I'm a little skeptical of that, but perhaps I'm wrong.
No, so the answer is basically no. You can't get the best performance out of an API like that, because you're right, is that you do need to change the API. So the
libraries that what did you say? SDL.
Let's take SDL and SFML as a good example.
Okay. All right. So they have stayed somewhat performant, but they're limited by the fact that they have the advantage is that the APIs have not changed.
Yes. So it's that SFML, for example, is very easy to use. If you're a beginner and you want to do graphics, I would 100% recommend it, because it's an excellent library, very high quality, but the performance is not amazing, right? It's not the best performance that you will ever get out of a graphics API. And that's just the way that it is. They've traded stability of the API and ease of use and, beginner friendliness and all of this kind of stuff for some performance. And it's not that the performance is bad, right? You can make games with it. I've made games with SFML. I've helped people make games with SFML. It's fine. You can do tons of stuff in it, and it's great. But if you really want that cutting edge of performance, you really want that maximum utilization, you're not going to get it through SFML.
And it's not because the implementers don't know what they're doing. It's because they've accepted the limitations that we're not going to break the API to do more heroic performance.
Yeah, you would end up having to have a much more complicated API. I mean, fundamentally, if you want the best performance out of your API, you have to have something like Vulkan. And in SFML, it's one line of code to make a window. In Vulkan, it's 1,000 lines of code to make a window. And somebody at some point, literally 1,000 lines of code. And somebody at some point has gone, it's not worth it.
Yeah, sure.
I just want to make a window and I just want to draw stuff to it.
But in the standard, that's what for C++, that's our standard, is that there can't be a language that's underneath C++. It has to be as efficient as it can be.
Yeah, it's both sort of true and both sort of not true, because there's a lot of, coming from game development, people don't use the standard library because it's not very fast. So if you were to standardize graphics in C++ that wasn't the most performant, but it was something like SDL or SML that was actually quite good, it's had a standard API that people use for a long time, and people build stuff with it. Like, people really build stuff with both of those. Like, they're both useful pieces of functionality. Even though it's not the best performance that you could possibly get, I still think there'd probably be quite a lot of value in that.
Okay.
Hypothetically, if it were possible to standardize graphics, if you could make it good enough, then yeah. I don't think we have to meet an absolute bar of performance, because otherwise people who want that are already using Vulkan. They're already using these low-level technologies to get the absolute
and there's a certain truth to that. I mean, if you were really looking for high performance, not only are you not going to use the streams for, I'm talking about if you're doing I/O, and you're not going to use not just the streams, but you wouldn't even use the format, which is a better library in a lot of ways, but you would really want to write something that is platform specific. In other words, the first thing you'd say is, look, I really want high performance. I'm going to throw away portability, and I'm going to use the OS calls directly, because there's an abstraction penalty there.
Yeah, or you go and find a library that somebody else has made that does it really fast and breaks the API and doesn't have a stable API, and you don't have to worry about any of it.
Sure. Okay, so I sidetracked you by talking about Cairo. So you read the proposal, and you had kind of just read it and you grumbled on Reddit, and then now you said, okay, I'm going to write this formally. You looked at it a little more closely.
Yeah, so I basically started reading through the graphics proposal once STL sent me this message, because I thought, why not? It'll be interesting to write a paper about this. I really should write something constructive rather than just whinging on Reddit, because, you know, I think we do too much whinging on Reddit collectively without doing anything useful. It is fun. I love doing it. But yes, I thought I'll note those down. So I started looking through the graphics proposal, and I found, you know, you find loads of mistakes that people make with color management. It was fairly straightforward. But I think the kind of, because some of that can be fixed. The kind of more interesting bit is whether or not this is the kind of API we want as a graphics API in C++, whether or not it has the legs and longevity to actually survive for 30, 40 years as something that people are going to put in their implementations is, I think, the kind of the more interesting question. And I'm not convinced that the current proposal, the performance is going to be too dodgy with the current proposal for people to use it as it is currently. And in 20 years' time, the performance of it will be completely, you won't be able to render anything with it, any kind of performance. So
are you saying that the color management part could be fixed?
Yeah. So I'm actually talking with the authors at the moment about how to fix the graphics proposal's color management. There's a lot of stuff that needs to be done. I think they need to take out all of the texture support, which is a bit sketchy. But if you take out all the texture support and then you introduce a couple more types, you can get strong typing Unreal Engine style, and then you let the implementation just decide what's going on with the format. Mm-hmm. I think you can fix it. And I think you can get linear color out of the other end. I think you can do all of your blending correctly. Mm-hmm. So that's, yeah, I'm providing advice on that at the moment, because I would like to see it be correct, if nothing else.
But you're less optimistic that the rest of the proposal can be done in a way that would have sufficient performance for a C++ standard library.
Yeah, I think that the performance of the rest of the proposal, if it was a TS now, I think what we would find is that it performs much worse than SDL or SFML or something like that. I think one of the arguments that I make is that it's very hard to implement additional functionality into it because of the way that it's designed. And so it will be much less functional than equivalent libraries like SFML or SDL. It's going to be tricky to fix that. So one of the arguments I make in the paper is that they don't separate types out into CPU and stuff that can be implemented on a CPU and stuff that can be implemented on a GPU if you want to. And that makes it very tricky to get good performance out of the API, because that's a very old style API that existed 20 years ago. And the industry kind of moved past that, because it's basically just tricky to get good performance out of that for a wide variety of reasons. So yes, it's that requires a lot more work to fix. It requires basically a major redesign to the way that the graphics API operates currently. That's the thing that I think is most problematic about the graphics proposal currently.
Okay. Was there anything else that you wanted to beat up on it now that we've pretty?
I feel bad because it's a lot of work that's been put into it, and it's
you know, that's one of the things that when people talked about it is everybody was like, these are smart people who worked really hard to get this into a proposal. And the killer was, it should have been, the committee should have stood up a lot earlier in the process and said, this is a mistake, don't go down this road. Because as you said, the people who are doing this are very sincere, very smart. They've put a lot of effort into it. And, you know, I think the fault here is that when a proposal comes before the committee, it's tough to say, yeah, let's take this now. It's tough to say, no, we're not interested. It's really easy to say, why don't you go and make a whole bunch of changes and we'll see if it's better next time. And that's an easy thing for you to say as a committee member. But what you're really, for one thing, you're obligating the committee to spend more time on it, because they will come back, and you're encouraging the person making the submission when in fact you might be more charitable to say, this doesn't have a future.
Yeah, well, the thing is, right, is that graphics it's really complicated, and I've been doing 2D graphics particularly for a long time, and I wouldn't want to write a proposal about it because it's going to be complicated. You're going to make mistakes, and you've got a small group of people trying to make something for a very extended period of time, and it's hard to get feedback on it. So the graphics proposal is going to keep going, right, and people are going to keep developing. And one of the new directions, which I think is a much better direction for it, is that instead of trying to just make this giant monolithic TS, which is 267 pages long, that I had to read several times and try and review, instead you break it up into smaller chunks, right? So we've got linear algebra, there's a linear algebra proposal going on at the moment, and that will remove all of the linear algebra out of the graphics proposal. And then me and Guy Davidson are working on a color proposal, which is for strongly typed, correctly done color conversion so that people can never mess it up ever again. It will make my life so much easier. And then you just do it incrementally in bits. You standardize each bit that the graphics proposal needs in C++. And then at the end, if you need to do graphics, it's so much smaller. It's much easier to review. And I think part of the problem is just that because it's so huge, it took me ages to get through it and to really understand what was going on. And I could only really review small bits of it. Like I only really know about color management and 2D graphics. And it's very difficult for, you want to get investment from a group of experts to go and review a 267-page long paper and then produce their own 20-page long paper, go to Prague, present it, do all of this sort of stuff to be able to get that kind of feedback back.
Right. Which, as you pointed out, with only 6 people on the committee that are graphics people,
it's difficult.
Yeah. And I'm not, one of the arguments that was made to me is, because I was saying, look, this just doesn't belong here. One of the arguments is, look, what we need to do is establish vocabulary types, because if you have third-party libraries, but they don't have any common data structure that they can share, that's problematic. Whereas if you were to say, look, here's the format of what a date looks like, even if you didn't do any date functions at all, if the standards committee, which of course they do with Cronus, I'm just saying as a hypothetical, if you just said, look, this is how dates should be stored, then everybody can go out and write their own date libraries to do whatever they want and say, and this is how we interchange if you have a function, And in fact, the argument that Vinny Falco made about, he wrote his own library for parsing XML. It's like, why do we need another one of those? And he said, because everybody who's written these has focused on performance of the parsing, which you can see why they would. But he says, that's not the important thing. The important thing is the data structure you put it into.
Yeah.
Because if we standardize the data structure, then somebody else could write a new parser in the future and everyone can use it. And in fact, could easily adapt a new library if we have an idea for this is how XML should be stored in memory. And that's why he wrote his own. It's like, because he focused on that instead of on optimizing the parser. And of course, being Vinny, the parser is screamingly faster. So
that's one of the fundamental problems with color is that the data storage types that people use for it are just all wrong. And so if you could establish a common data type or set of data types, you're going to end up with templates involved everywhere. But you establish a common data type that everybody can use, it would make everybody's life a lot easier, because suddenly every library could provide an overload that just said, oh yeah, and we also take the stud color type. Or we take a stud sRGB, or we take a stud linear color, and then it becomes massively more difficult to mess it up. Even if you don't provide that much extra on top of that, although I'm planning to provide, conversion functions and stuff like that.
Sure.
It would fix a lot of the industry, I think, quite rapidly, which would be great.
Yeah. Now that is the proper role for the committee, I think. And that suddenly you've won me over. I'm really skeptical about what we have now, but also, again, it's not, well, I've told you what I thought about Cairo, but it's not just that, it's the very idea of what we're trying to do. Is this appropriate for the standards committee? On the other hand, what you just talked about and said, okay, let's talk about some fundamental vocabulary types that people could build libraries on. Suddenly you've got me thinking that maybe there's a role for the committee there.
I think that what will happen is that we'll standardize these vocabulary types, right? So we'll get linear algebra, we'll get color management, and then I believe it's geometry that they're going to try and get standardized. And we'll standardize all of these parts. And so a lot of graphics will incidentally have been standardized, but they'll have been standardized for, in the in a wider variety of usages. So we'll have a proper, really cool linear algebra type that people can use. You can just have a vector that you can multiply with something else. It'll be great. And we'll have a color type that you can use for all kinds of color management. And then graphics it won't fall out at the end. You still have to standardize graphics if you want to standardize graphics, but so much stuff has already been done that you're arguing about the structure of how the data types in graphics should be done, rather than arguing about, well, is the color management correct? Because the color management is correct because it's already been standardized. So I think that will make it a lot easier to figure out what on earth is going on with 2D graphics, because it'll shrink the proposal massively as well.
So before the show, we were chatting about audio. And
yes.
One of the things I said is that, audio is all about, the challenges there about keeping things in real time. We've had this discussion on previous podcasts. And so I said, I didn't really see that there's a lot of overlap, but what you pointed out, and you convinced me, I see it now, that the real issue is how the data is stored, because how you store different types of audio data, different bit depths, different sampling times, all sorts of different things. And you want to be able to mix those so that you can play those, and there's all sorts of things. That's essentially analogous to storing color data, because again, if I have a large data set, whether it's a photo or a movie, I want to compress that data as much as I can, and I have to figure out, well, what are the trade-offs involved? How much am I willing to compress? And so it does have some similarities. And one of the things that's kind of interesting is that the audio, again, in the entire standards committee, there's a handful of people who know anything about audio, right? But they're getting some success in what they're asking for. And one of the interesting things about what they're asking for is, if you look at the proposal, some naive person would say, what does this have to do with audio? Because it doesn't really, not standardizing, here's the interface to the sound chips on these different devices. No. All they're standardizing is, well, this is what, we just need a data structure that looks like this. Yep. And that data structure could hold anything. It could hold audio data. It could hold color data. So it is kind of interesting. And again, it's kind of what you're talking about is, well, let's just pick the low hanging fruit that becomes a vocabulary thing and put that in the standard. And maybe we don't need to go any further. And I think that's what the audio people are saying is, you give us this, that's going to make our lives much easier.
Yeah. Particularly, I think is doing the difficult bits of API design that people mess up. I think that's what the C++ people really want to standardize. Is you want to get somebody who knows the problems, who's been through the pain of all of the APIs being wrong. And the audio guys are great and they know what they're doing. So you really just want them to go, okay, these are the problems that everybody runs into. This bit is standardizable. Let's just fix this forever so that nobody ever has to worry about this ever again. And then C++ just becomes much more useful. It becomes much more useful to do graphics if we get a color type, because then it will have best-in-class color support that just isn't wrong. Nobody has to roll their own ad hoc types anymore to do stuff. And that seems like fundamentally what we need to be trying to standardize, that kind of stuff.
So asking you to look into your crystal ball, if the standards committee actually did standardize color types in the way that you're thinking of, are any of these game engines going to be, obviously Unreal wouldn't have to be, but would the others, are they going to reverse engineer? Is it possible for them to do it? Or are we just talking about them, they've just done it so wrong and there's really no way to fix it?
So there's compromises that you could make. So for example, in SFML, one of the problems that it has in the linear color mode is that you lose loads of precision. But what you can do is you can say, well, that's acceptable. I'll define a conversion so that I can convert my stud color to a SF color. And then I'll just accept that when SFML is in this mode, I'll lose precision. And so you can make that compromise in user code where you're using a library that's built incorrectly. The other thing that you can do is that hopefully we'll be able to update SFML if a color type gets standardized and just provide a new set of overloads. So ImgUI is a good example. It's a little C++ UI tool. I say little, everybody uses it for everything, and it's great. But hopefully what we could get in there would be a new set of overloads so that you can say, well, instead of the old 32-bit thing that you pass in a new stud color type. And then the old API doesn't go away. Everything just, if you were using the old code, it still keeps working as brokenly as it did before. But then code using the new stuff would be correct, and it would be hard to mess up. So that's the ideal there, would be that we could get existing APIs to update to standard C++, which would be correct, and it would make my life, I would be so happy.
But that would mean, from the library's point of view, they're storing data internally as 32-bit. So now they would make this choice, because if they take a standard color and just map it to a 32-bit, it's not a huge win. So the other choice for them is, well, they could take the old API and map that to the standard color, but now they may have blown up their storage requirements.
Yeah, well, done
the
correctly.
Are maybe looking at some tough choices there.
Yeah, so there are some trade-offs to be made in doing it correctly. The thing is that the trade-offs that you have to make in doing it correctly are, I want it to be correct versus wrong. So if you want correct linear color, you're going to have to use more storage than if you want incorrect, done wrong linear color. So yeah, in particularly in 2D graphics APIs, you don't have to worry about it so much, because the storage space for them is never that huge. And the underlying textures, importantly, don't need to have their storage space increased. You can still keep all the textures the same precision and same everything that they were before. So actually, the main overhead is passing a color into the API, where you go, oh, I want to draw something red. You have to specify your red color, and that will have to be floats rather than being 4 UINs. But that's not like a massive problem, to be honest. So I hope that it will all pan out great.
All right.
I think we can definitely say that color is not black and white.
Wow.
Well, this has been a very colorful discussion.
Oh, dear.
Were there things that we wanted to explore more? I think I already asked you if there was other stuff you wanted to beat up on this proposal. You attended Prague?
Yes, yeah, I was at Prague. I presented to SG13 for an hour and 15 minutes about this. I felt bad for them, but
did they invite you back? That's the question.
Yeah, surprisingly enough, they actually did. It went quite well, so I was pleased about that.
Okay. Are you coming back?
Yeah, so hopefully in I believe it's Varna, I will have a color proposal along with Guy Davidson, who's a co-author. Hopefully I'll be presenting that then. Inevitably, people will find loads of things wrong with it, but I'm quite looking forward to it.
Actually, as negative as you make that sound, that's really what you want, is for people to find loads of things.
Yeah,
wrong.
absolutely. I want people to look at this and go, this is terrible, fix this, fix that, fix this, fix that. Because I want it to be right.
Exactly.
I'm going to have to use this in my own job doing work with game developers. So if it's wrong, I'm just making my own life harder.
So I would encourage you to, post it on Reddit and say, what is it that you put on the table? You say, this is a perfect proposal. Convince me I'm wrong. Because of the fact that there's not enough game people, and certainly there are no color experts on the committee. So the thing for you to do is to seek other people's output, or opinions, because just going to the committee, I suspect they're just going to essentially say, okay, you're the expert. Yep. And that's not what we really want.
Yeah, that's what I actively want to avoid is a lack of scrutiny about it. So the proposal hopefully won't be that long, but you will need to understand color management to understand whether or not it's correct, because you have to worry about implementation divergence when you're doing various kinds of optimizations and stuff like that. So people will need to look at it and go, oh, this is actually, you've completely done this the most horribly wrong way in the entire universe. Here's a better way to do it. So
do you have Sean Parent's email address?
No, I don't.
I've never talked about color with Sean, but while I don't know if he's an expert on color, I absolutely know there are people at his company that are experts on color.
All right. Yeah, the takeaway from this is that I think my email will be published somewhere. Come and email me. If you find anything wrong with anything that I've said, send me a long, angry email, or just post on Reddit telling me I'm stupid. I love it. I love it when people tell me I'm wrong, because then I can know that I can learn more about it. So just insult me, tell me I'm a bad person, say awful things to me, but also tell me what I'm doing wrong, and I'll be really interested.
Okay. Well,
it's a good takeaway for the show there.
Yeah. Well, it's been a great discussion, and time has just flown by. I think we're at the end. Did you have anything you wanted to say, Phil, other than some colorful pun?
He's a blue collar worker over there.
No, I think we covered it in well, thoroughly.
All right.
No, we didn't.
No, we
so
didn't.
much more.
There's so much more.
I was being optimistic.
Oh.
Yeah. Well, I want to say that I enjoyed reading your review. I thought you were you made the points you made. You made them diplomatically. I suspect there were a few times as I was reading this that you wished you were using stronger language and you had restrained.
I reworded it a lot to make it as polite as humanly possible, because I have a tendency to go, oh, this is all terrible, and then I wanted it, because the authors put a huge amount of work into it, and it's
Yes.
not terrible.
Yes.
It's
No.
all right.
Yeah.
It's fine. It's just there's problems with it that need to be addressed.
Right.
So that's what I really wanted to get was, this is the technical issues. Let's be technical about this, and I'm gonna word this helpfully.
Yeah. I will say that engineers do have a tendency to be black and white about stuff. It's like, hey, there's this problem. This whole thing's bullshit. And can't always express things. When I moderate comments on the YouTube channels for the conferences, very often there's a comment that's both thoughtful and thoughtless. And it's like, this is bullshit, blah blah blah. And the blah 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 is like, yeah, there's might be something to say, but I'm not going to let this comment go through because this is just the wrong tone. So
I think it's very important to take the right tone in this kind of thing. Everybody's got to be friendly, respectful, and helpful to each other. Which, frankly, everything was in the committee when I went. It was all just technical stuff. Everybody was very lovely.
Sure, and the thing to keep in mind is that even when someone is making an argument that you don't think has technical merits, they are making it for the best of reasons. There's nobody on the standards committee who's saying, we'll get them all to use Rust eventually. We'll make C++ so unusable they have to use Rust. That's just not happening, right? I mean, everybody's heart's in the right place.
It's Biana. He's the sleeper agent.
Yeah, that's right. Anyway, so we should probably wind this up and wish everyone who is listening safe coding.
Safe coding.
Safe coding.